Hello guys, welcome back. Welcome to the Statistics Analytics Department and a very good evening to you. Let's solve today's 20th August problem, and it's a real analysis problem from differential calculus. So let's solve it. Let me just check if my voice is perfectly working or not. Yeah, I think it's perfectly working. Okay, so coming back to the problem and let's see the solution. If you have not solved the problem, please don't watch the video. It's for your own good. If after that you want to continue, it's up to you. Okay, so if you don't know where the problem is, the problem is in the website. The link is given in the description below. Okay, or you can pause the video, solve the problem yourself, and come back again later on. Okay, that's it. So yeah, just give me a minute, guys. Okay, so yeah, welcome back. I hope you have seen the problem. You have tried yourself. Let's solve the problem now. So the problem asks that for which value of x, or sorry, for which value of k, this cubic polynomial has only exactly one real root. Okay, so you know that from a theory of algebra, cubic polynomial will at most have three real roots, and yeah, at most have three real roots, and also let's use something interesting. Okay, so it's a cubic polynomial, and x cube minus 6x squared plus 9x plus k. X cube minus 6x squared plus 9x. Am I doing? Yeah. Plus k. So this is the cubic polynomial, and we know that the number of roots is at most 3 and greater than or equal to 1. Because we are using something called intermediate value property. Intermediate value property, or rather theorem, which tells that a continuous function. So yeah, I hope you know the result. It tells that. An application of that is the following: that if a continuous function takes values positive and negative, it's an application exactly not that theorem. It tells that if a continuous function takes values positive and negative, then somewhere in between it will take 0. Okay, because it's a continuous function, so it's an application of that. So since cubic function, let's see cubic function. If you let limit n extends to infinity, x is cube minus 3x square plus 9x plus k, this must be infinity, right? And limit x tends to minus infinity, x is cube minus 6x square plus 9x plus k is equal to minus infinity. This is the basic idea. Okay, and therefore it takes both positive and negative values. Minus infinity, like that means it must take in some negative value and it must take some positive value. So in between it must take at least 1 0, because it's a continuous function. Polynomials are continuous functions. So we're using IVT. It's going infinity, it's going plus infinity. So under somewhere it will be 0. Okay, it will take the value 0. This is a application of exactly IVT. Or IVP, whatever you speak. It's fixed the number of roots. So it may need much more sophisticated mathematical technology to understand that. Okay. So let's understand the function first. 6x cube minus x cube minus 6x squared plus 9x plus k. So the first idea is that let's not think what is this k doing. If you understand what is this key doing, this is called location change. So if you have a function like this, let's say fx, which looks like this, let's say, if you add 2 to it, what will happen? If you add 2 to it, the function will just move against 2. If you subtract 3, the function will move below 3 by 3 units. This is a basic idea, right? So it's asking that, so the one idea can be, what if we can draw this function and see the diagram of that such that, so let's draw this function and then I will understand the rest of the part. So let's draw this diagram. Let's understand, let's curve the sketch. Let's sketch the curve, I'm so sorry, let's sketch the curve of this function. And x cube minus 6x square plus 9x. And then we can move on to what this really k is doing to the function. Okay, this is the basic idea. So let's draw this function. So to draw this function, we need, so as you know, differential calculus is a technique to first do the derivative. But if you see, we don't need a derivative, we can also do it. If you just take x, you see x square minus 6x plus 9. The beautiful part is that it's x into, it is a square over here, x minus 3 whole square. So how to draw this function? This is a really important idea, how to draw this function. And that's why differential calculus is something called wavy curve method. So let's say we have a function whose roots are 0, 3, and some 3 plus some value, 3 plus epsilon, and 3 and 0. Okay? Or let's say a function which has roots 3, 3 plus epsilon, and 3 minus epsilon, let's say. And here is 3. Okay? So let's say the function, the polynomial has roots this, and that. So understand that also, like, it's a very critical idea. Okay, so understand this very, very, very carefully. So the cubic function has 3 roots, x, the roots are 0, 3 minus epsilon, and 3 plus epsilon. And we know that it must start, like, it starts with x cube, so it must start from here, and it must end here, because the x tends to infinity, it must be minus infinity. Why x cube? Because the polynomial is the degree 3, because it has 3 roots, so it must have degree 3. So it's coming down, so here is 0, and it must go down here, okay? And here it's going up. So the function looks like what? The function looks like x minus 3 plus epsilon into x minus 3 plus epsilon and minus epsilon. And if you draw the function carefully, if you think about it, it's called wavy curve method. You can search about it. You can see that the function of this will look like this. Let me draw it carefully. Yeah, the function is looking like this. But here, the roots are not 3 minus epsilon or 3 plus epsilon. Here, the roots are 0, 3, and 3. In some senses, epsilon is going towards, in some senses, epsilon is going towards 0, it's shrinking towards 0. So what will it look like? If you understand, it will look like this. It will go to 0, and then it's going close like this, right? And it's going close like this, and close like this, as epsilon is going towards 0. So what will happen? It will just look like it's kissing the surface of 3, and it's going above. And that's the exact, that's how x into x minus 3 whole square looks like. And this is, we have done it by the method called wavy curve method. Okay, and it's very important to understand this method for curve sketching aspect. Okay, now let's try to understand how we can use this for this problem. So we have drawn the graph of this. So we have drawn the graph of x cube minus 6x square plus 9x, this part. And it looks like this. 0 here and 3 here. So it looks like this. Perfect. So we are adding a k over here. It's negative, it can be positive. It's negative, it will go down like this. If it's positive, it will go up like this. If k is positive, it will go up like this. The graph of this function, I mean, including the k. So we need only exactly one root. And when can that happen? For each value that can happen. Understand it. That can only happen if, so the two roots can only happen if this is the case. This is the diagram. If you draw it down, until you bring it down, such that it looks like this. That it looks like this. Or it looks like this. These are two cases, there are exactly two roots. Okay. अंदर वाला cases all are 3 roots. Outside this, so here at this band, it's 2 roots. Under it's all 3. Under it's any curve low, it's all 3. So if you like, I'm just taking the values of k. And if you take other than this, it will all go above. So it will exactly have 1 root here. And if you take this case, it will all go here. So it is exactly from here above and here below. For those values of k, the function will have exactly 1 root. Okay, this is the basic idea. So how to find the values of k? How to find the values of k for which it will have exactly such 1 root? So to find the values of k, we need to find out these values when it has exactly 2 roots. So this is the actual graph. So in this case, we are down. So if k is 0, that means it's going up. So for k greater than 0, it has exactly 1 root, as explained below. Before, right? For k less than certain value, it will be certain thing as it will be also having a root 0. So let's calculate that value, and that exactly value is this height, the maximum height, this height, the maximum height that it's reaching. So if we subtract that, it will become like this. The graph will look like this, exactly 1 root. And if you take k greater than 0, it will also have 1 root because this will go up. So what exactly is happening? It's happening the following. Just give me a minute. What exactly is happening? That you have to calculate this height now. Okay, you have to calculate this height now, and this is super important. How do you calculate this height of this function? So understand, k is greater than 0, or k must be less than equal to minus of the maximum height, like this height h. This is a positive value, so minus of h. Because if you do that, the graph will become will look like this. So it's a graph drawing problem, curve stretching problem. It's a very important idea. If you have seen Avinav Shukla's preparation strategy, he has told curve stretching is one of the most important ideas. You need to learn that. For that, a good book is Arihant ka curve tracing book. Play with graphs, bolke. So we have to find that maximum height. Here is 0, here is 3, and we have seen that the maximum height is this. So we have seen for k greater than 0, it's only one value. For k less than h, this is the height h. So how do you find the height h? It's very easy. You just find the local maxima. So fx is what? X cube minus 6x square plus 9x. You do f dash of x, you get 3x square minus 12x plus 9. So if you take out common 3, x square minus 4x plus 9. Plus 3. You can understand it's 3 into x minus 1 and x minus 3. And you can see the minimum occurs here, so the maximum must occur at 1. And let's compute the value. So therefore, f of 1 is equal to h, and you need not even do the f double dash x. So that's the beauty of curve tracing, okay? You can actually find the, you can actually interpret without doing the entire thing. That's the beauty of curve tracing. The curve, you can like actually interpret without doing the double derivatives, okay? That's the intuition. That's the beauty of it. So f of 1 is equal to h. So let's calculate f of 1. So h is coming out to 1 cube minus 6 plus 9. That is minus 5, 4. So this height is 4. So therefore, if k is less than minus 4, then this will be in this region. The graph will be in this region, this blue type, this type of graph. If k is greater than 0, it will be in this region, like this. So these are the values of k less than minus 4 and k greater than 4. जिसके लिए this function will be having exactly 1 root. So k greater than 0 and k less than minus 4 के लिए only exactly 1 root. K is equal to 4 and k is equal to 0 के लिए exactly 2 roots. And k less than 0, k less than 4 and greater than, minus 4. This is minus 4 and 0 के लिए exactly 2 roots. And k less than minus 4 sorry, greater than -4 and less than 0 के लिए exactly 3 roots. So this is a distinction. This is called phase curve maybe. So phase space. So this value of k parameters phase space of this k, you will have the different roots, number of roots. Okay. This is a really beautiful problem of real analysis. It includes all of the independent value theorem, understanding curve tracing, which is super important, understanding a method called Wavy curve method, and understanding for which how to apply, find the maximum using the differential calculus tools. So these are super important, guys, and you must learn this problem solving strategy step by step. So if you're enjoying this problem solving stuff, do like and share with your friends. So we are solving a problem every single day. We're trying to solve a problem. Let's see if we can keep up that consistent behavior and help you guys in learning and preparing for the exams you're like preparing for. All the best, guys, and thank you for your support. If you are liking this video, please like, share, and comment, and share with your friends who love to solve problems and who are preparing for various examinations and whatever, enhancing their skills and building their foundations. Okay, all the best, guys, and yep, bye bye, and I will see you in the next video. Stay tuned and stay blessed. Do subscribe to our channel.